Hey guys, hope you are doing well. Welcome to my YouTube channel. If you like, please subscribe, like and comment. So today we shall look at one of the chemistry aspects, and today we shall be looking at chemistry bonding, or bonding in simple terms. So what is bonding? Mainly this word bonding, it may also mean like to bring something together. For instance, you have had an argument with your fellow friends, and you want to bring back the lost friendship. You want to reconcile again. So when you reconcile again and you became friends again, that's what is referred to as bonding, like bringing two things together. So but at the first you are separate, but at the end you have come together. So that is in human beings or in animals. That is bonding, just a union of two or more objects or people. So in chemistry, bonding also means the same. Just in chemistry, the definition only, it is the one that differs. In chemistry, the definition only differs, but it is the same. So in chemistry, they only change, they put only the word chemical. So in chemistry, bonding is the chemical union, between two atoms. So it is just a union, a togetherness that attracts two atoms to become together. So that is bonding in chemistry. So another thing we need to know here, in chemistry we shall deal with three types of bonding. Three types of bonding. Now these are ionic bonding, two covalent bonding, and for the last one it will be metallic bonding. Metallic bonding. So our aim today, it will mainly focus on we shall focus on ionic bonding. That is our main aim today. So we shall look at the other two types of bonding in the next videos, but for today let us understand ionic. As you hear the word ionic, so ionic bonding, so ionic bonding in simple terms, it is the type of bonding where a metal reacts with a non-metal to form a compound. So in this type of bonding we shall need two components, mainly two components, and one it will be metal, and two it will be a non-metal. So those are the components of ionic bonding. So in ionic bonding, as you hear the word ionic, so here we shall form ions at the end. We shall form what? Ions. So what you should know in this type of bonding, in this type of bonding of the ionic, metals lose their electrons, in brackets their valence electrons. Metals lose their valence electrons to obtain a noble gas structure. In this type of bonding, metals usually lose their electrons. So what happens when metals lose electrons? Remember, when metals lose electrons, they form positive charge. So after losing their electrons, they form positive charges, or you can call them positive ions. So the symbol for positive, as I told you, it is addition sign. It is an addition sign. So another thing, so here what you should know, that metals usually donate their electrons to where? That's where we are going to see. So metals, after losing their electrons, these electrons that have been lost by metals, they are usually gained by some non-metals, because what you should know, that these non-metals usually gain electrons. Non-metals gain electrons, while metals lose electrons. So after these metals lose their electrons, non-metals gain these electrons. So non-metals gain these electrons which were lost by metals. So after metals losing their electrons, these electrons are gained by non-metals. So that is some of the basics you should know when you are dealing with ionic bonds. And the symbol for after they gain these electrons, they form negative charges. They form negative charges or ions, or negative ions. So you can call them either charges or ions. So these are some of the basics you should know. The first one, metals lose their electron. The second one, non-metals gain these electrons which were lost by the metals. So the next thing we are going to discuss, for you to understand better, we need an example of an ionic bonding. So one of the components, we said you need to have a metal. You need to have a metal, and we say that all metals have positive charges. All metals have positive charges. I'll give you a link in my description where I discussed about ions. So you will see how metals have positive charges and how non-metals have positive charges. So non-metals usually have negative charges, metals usually have positive charges. Now an example that we shall be looking at, it is a formation of an ionic bonding between sodium and chlorine, to form sodium chloride. So this is an example we shall look at. Formation of an ionic bonding between sodium is a metal, and chlorine So the chlorine is a non-metal. I said I will give you a link in my description to see why chlorine is referred to as a non-metal and why sodium is referred to as a metal, and even the periodic table I all explained this. So to form sodium chloride, so sodium chloride, it is a product formed after sodium has reacted with chlorine. So firstly, before doing anything, just identify of these two elements given to me, who is a metal, who is a non-metal. So a metal, in our case, we have already identified it. It is sodium. It is sodium. What about a non-metal? What about a non-metal? So a non-metal, in this case, it is chlorine. After identifying this, now you have found the components of ionic bonding. You have identified a metal and you have also identified a non-metal. So we say that metals lose their electrons. Chlorine gain electrons. Why chlorine is a non-metal? So this is what you should know. For element to obtain a noble gas structure, for any element to obtain a noble gas structure, what do I mean when I say noble gas structure? So a noble gas structure is that structure that is fully complete. It does not either need to lose or gain. For it is stable enough. It is stable enough. So these elements also go under bonding in order to obtain that noble gas structure. So what happens when sodium loses its electrons? It can be referred to as a noble gas structure, and also chlorine at the same time. Now, as I told you in one of my videos, I also put a link in my description, that these metals, when they lose their electrons, they form positive, and non-metals form negative electrons. Now, so what we are going to see is that sodium reacting with chlorine, how are the ions exchanged there? So here you will also need to know their valences. You need to know their valences. You will need to know their valences. So you will see that sodium has a valence of 1. While chlorine has also a valence of 1. But remember, sodium is a metal. Remember, sodium is a what? A metal. So this valence of 1, it is represented by a plus sign or an addition sign under ions. For chlorine, it is a non-metal, and this valence of 1, it is represented by a negative sign. Yeah. So for you to understand this, I'm going to give you a structure, but under this structure of the ionic bonding, you should also know their electron configuration. I also made a video on how to determine the electron configuration of different elements. I explained how to get the configuration in terms of ratio forms and in terms of orbitals. I'm going to also give you a link in the description so that you can also watch this if it is becoming difficult for you to understand. My main issue is for you to understand. That's why I want your comments. Anyone who is like arguing how can I get this, I'm happy and I will be able, inshallah, to give you my responses and to help you out. So the configuration, you will need the electronic configuration. Now, electronic configuration of sodium is 2 to ratio 8 to ratio 1. For chlorine is 2 to ratio 8 to ratio 7. When you know this electron configuration. If you know this electron so this is in ratio form. This is the electronic configuration of ratio form. So if you know this, now you can draw their structures, because each number or each digit you see in this ratio form represents a shell. So let us draw these shells, and we see like how this sodium loses its one electron and it donates that electron to chlorine. Now at the end, how are they, or why are they referred to as noble structures, or how can they really obtain that noble structures to be called that those elements are octet? Because after bonding, these elements becomes ions with a double gas structure, or in brackets it can be called octet. So octet also means like something it is fully, it does not need anything, so it can stand on its own. So let us see how we can do this. So for sodium, this is its symbol. So we have seen its configuration, it is 2 to 8 to 1. So 2 represents the first shell. Now 8 represents for the second shell, and chlorine represents the last one represents the third shell. So that is sodium. Now what about chlorine? So chlorine has a symbol of Cl. Now the first 2 on the chlorine configuration, it represents also the first shell. The second, the 8 represents the third shell, and the 7 represents the third shell. So after doing that, now start putting these numbers in terms of their electrons, because for the 2 it is represented by this X. This X you are seeing represents the first shell, that it is fully complete. I made a video on this, so you should also see, because I also explained that for under these shells, or under this electron configuration, the first shell should have a maximum of 2. So for the first shell it is complete, and the second shell should have a maximum of 8. Then starting from the third shell, it can have more than 8 or any other, but a shell with 8 valence electrons, it is said to be completely full. So sodium in the second shell, it has 8. So do them. Those are 6, and then 8. And then the third shell has only 1. Now you come to chlorine. Chlorine also has, in the first shell, it is fully complete with 2 electrons. For the second shell, it has 8. 1, those are 6, 7, and 8. Now for its third shell, it has 7. It has 7 electrons. Valence electrons 7. So these are 4. These are 4. 5. 6. So when you are drawing these electrons, put them in pair form. Yeah, so don't just scatter them one by one. No, put them in square, no, in pair form. So those are over. So what happens here? Sodium will lose its valence electrons. Its valence electrons are those electrons that are found in the outermost shell. What do I mean by the outermost shell? The outermost shell is that shell that is last. Yeah, that is the final shell on the shells of that element. So here, for the last shell on sodium, it is this one, the third shell. It is the last one. It is the last one. It has only one electron. Now what will happen under ionic bonding? Under ionic bonding, this one electron of sodium will be lost, and it will migrate to the chlorine. It will migrate to chlorine. Now what will happen? Chlorine will obtain this electron, and it will be and you will do that electron. So meaning that for sodium, this electron was lost. This electron was lost. That meaning the third electron was with one electron of sodium, was with one. Now what will happen if that electron has one? The shell also disappears. The shell also disappears. The shell also disappears. The shell also disappears. So what happened? So sodium, which at first had 3 shells, now it has only 2. It has only 2. So now we saw that sodium before it had, so sodium now it will have electronic configuration of 2 8 2 8 280. Now what about for chlorine? After bonding, it will have electron configuration of 2 to ratio 8 to ratio 8. So sodium, that means the first shell it is completely full, and the second shell it is also completely full, because the second shell we said that it has a maximum of 8, and for the first shell it must have a maximum of 2. So here we say that sodium has obtained a noble gas structure. A noble gas structure. Now this goes the same for the chlorine. It also has 288. So if a shell has a maximum of 80 electrons, it is also said to be completely full. So chlorine also, it has obtained a noble gas structure. So I think now you have understand how these electrons are transferred from metals to non-metals. So if you have understand that, now you can also read this, because after that means we shall have ions. So sodium after bonding shall have a positive charge of that one, because in chemistry they don't consider one, so just put an addition sign. So also the same as chlorine after bonding shall have a negative charge of, instead of putting 1, just put a negative sign. It is enough. So in chemistry they don't usually consider 1, so just put their signs, that will be enough. So another thing that I want to share with you is that when you are dealing with ionic bonding, first identify the components. The components, it is a metal and a non-metal. Now after there, know their valence electrons. After knowing their valence electrons, know their electronic configuration, because the electronic configuration will help you to see how many electrons are moving from a metal to a non-metal. And after there, you should have at least, because for the what you should know under ionic bonding, one of the shells of metal will be lost. One of the shell of a metal will be lost, and for the shells of the non-metal will be maintained, but they will gain an extra electron. So I want to leave you with this question. It is not that hard if you have understood. Yeah, so I hope that you will do it and comment in the comment section so that I can prove if your answer is correct or wrong. If you have not understood, like somewhere I have explained but you have not understood well, you can also comment in the comment section. So this is the question. It is an activity. You can do it. It is an activity. It is only one. Yeah, it is only one. It says that atoms in element J and the element Q have proton numbers 12 and 17 respectively. And they say that explain what type of bond will form between J and Q. And another one, they want you to predict the formula of the compound formed. So I hope you find this video helpful. Please, if you have not understood somewhere, before I jump to covalent bond, I'm really waiting for your comments in the comment section so that I can help you with this. So I want you to answer that question. Put your answers in the comment section, and I will be happy to help you out or to confirm your answer if it is wrong or correct. And if it is wrong, we shall work it together so that you get the correct answer. I thank you all. Please like, subscribe and share for more videos. I hope to see you in the next video. It will be about covalent bonding. Thank you very much. Bye.